All right, next question deals with the photoelectric effect. So, in this apparatus, the photocathode and the collector are made from the same material. The potential V of the collector, measured relative to the ground, it is initially 0, and is then increased or decreased monotonically. The effect is described by Einstein's photoelectric equation, E V minus or equals h nu minus w. So let's just scribble that down. I have EV equals h nu minus w. So looking at that, I have that is the energy of the photon. That is the work function to do some stuff. Basically, it's to pop an electron off the electron C. That's a potential. That's what we're looking for. That is the electron, the electric charge, or the charge of electron charge. All right. So looking at that, we can do a couple things. If we know, there's kind of a phrase you have to know, stopping potential. If you don't know that, you're kind of limited to what you can eliminate. So if I know that, I can get rid of this one and this one. Boom, boom. And then that just doesn't really seem relevant, so you can get rid of that. So if you know stopping potential, you're left with A or C. Now, to figure out whether it's positive or negative, I will just do a little bit of moving around with the equation, bring the work function to the side, and therefore I'm left with this. And let's just do some signage stuff. So I have a negative, we'll leave that blank for right now, plus another positive, because it's a work function, work is positive. And then the energy of a photon is going to be positive, so I see that in order to make this work out, this has to be negative as well, which means I'm left with A as my answer. All right. And going on to the next one, we see that the photoelectric equation is derived under the assumption that electrons are restricted to the orbital of angular momentum, and it didn't really have any effect on it. The electron is associated with waves of wavelength. Really doesn't have an effect on it. Light is emitted only when electron jumps between orbits. Doesn't have anything to do with that one due to the fact that it's kind of individual photons. So you have D as it is absorbed in quanta, which is basically what the photoelectric effect, not really what it says, but it's based on it. All right, the next question's pretty simple. The quantity W in the photoelectric equation is, we actually already talked about it being the minimum energy, the work required to free an electron from that kind of electron C. So D is the answer.